All right, so welcome to the second Smart Grid Educational Series. Today we have the privilege of having Chris Blask of ISACS Cybersecurity present on information sharing. I think you will find this quite informative and innovative. He will also be talking about some of the work that he's doing in the industry through collaborative efforts. So with that, I'm going to pass the baton to Chris. And Chris, the floor is all yours.
Great. All right. Well, thank you very much, Irfan, for having me here. Everybody, I hope technology doesn't fail us. I'm sort of somewhere on the other side of the world on the 25th anniversary, but this is the kind of important to share a little information on information sharing. So I'm glad to be able to be here with you all today. I want to walk through the value of being informed. It's a fascinating part of all this when we look at, we all live in an information world and it's information technology, but what does even information mean? And the word itself, to be informed, to inform something. You know, we look at the data, we look at the information, we forget about the purpose. And the only reason we have this information is to do things with it. And information in a vacuum is generally fairly useless in the first place. So we'll talk a little bit about that. What is the value of information sharing? We'll talk about this information sharing architecture. We have some examples here, like the LIGHTS program and the ISACS and so forth we'll drill into. But you know, we firmly believe that there's a structure of information sharing that's arising relatively organically. And in the industrial control system world, there's public, private, and private centers. And the dynamic of these developing out tells us a lot about what we're doing. The ICS, ISAC, the Information Sharing and Analysis Centers are these federal public-private entities that have emerged over the last 15 years or so. We're now standing up an ICS, ISAC. We'll talk more about that. As Irfan's mentioned, my brother Brad Blask is our Vice President of Development here, and he is conceived and is driving the program to create the ICS, ISAC. We'll touch on the capabilities a facility needs to be able to produce information worth sharing, and then take information that's being shared by other people and do anything with it. And then we'll frame all this up, hopefully, in the context of a nonprofit program that's just being launched called LIGHTS. So without further ado, so what is the value of being informed? Well, first off, what you don't know definitely can hurt you. And as we look at industrial control system cybersecurity, how do we fix the grid? How do we fix the water systems? How do we fix the hundreds of thousands of industrial control systems that we have in the country? One of the things that becomes quite clear is that if you're an electrical co-op, if you're a water facility, if you're a manufacturing facility, and you live in an island, and as far as you know, there are no attacks going on in the world, no one's having any problems, no one's developing the best practice, then the first time you hear about anything, it'll be because it just happened to you. This really goes all the way back to in my early days I dreamt up one of the early firewalls that nobody certainly remembers anymore. But the very first day, the very first show, someone said, how do I know that this thing is perfect? How do I know that this firewall will really keep people out? And that's kind of a tough question. And the answer then and ever since has been, well, you're not really buying a product. What you're doing is you're buying a relationship with a group of engineers who are really smart, and they take this very seriously. They take it personally. If someone breaks this product we're selling or this service or this system, in our context, we're looking at a national system, there are people who will stay awake on caffeine and anger until it's fixed. And that's the real value. It's never about the technology. It's not about the things we do. It's about the people we're related to. And in critical infrastructure, the cost versus benefit of information sharing is one of the elephants in the room. And cost is not necessarily always dollars. There's certainly dollars have to be spent to take you from where we are right now to somewhere else. But the cost and risk is, I think, one of the greater impediments right now. classic example in the electrical sector, as a utility, you can understand that sharing information about your experience can benefit everybody and maybe benefit yourself. But if you're sharing it with, I don't know, the regulators or the government, you may be reticent. You may have certain hesitations that you might not have in other ways. So balancing that benefit, being clear on what the benefit is from an information sharing center to a utility, to an entity, for example, needs to be clear, and managing the cost. Let's reduce the risk to the information sharing partners. Let's be clear about it, and let's be clear about that next point. Whose information is it? That as a utility, the information going on inside your network is yours. Not forgetting, of course, other entities you may answer to. In industrial control systems, it actually gets easier when you think cross-sector sometimes. With a manufacturing facility, there's certainly it's their information, short of OSHA or something like that. And clarifying that throughout the chain, we'll talk about that your information really is yours, that the regulators aren't really interested and don't have a right to certain parts of it, and so on and so forth, is another important part of balancing that interest scale. And trust but verify. That as we dig deeper into information sharing than we have today, as we get beyond the couple hundred, the Fortune 500, and address all 3,200 electric utilities, all 100,000 water utilities, and so forth, we need to be more and more clear that as we're asking people to share information, we're not asking them to perform a leap of faith, that they're working with quantifiable known factors. So I hope this, good. So there's a certain information structure that needs to exist. We start with facilities. The facilities have all the information really worth having, or at least the vast majority of it. Certainly we find things through the research space and the crime space, but most of what we need to know is already known, or the information already exists inside the facilities. So we have all sorts of facilities in this country. Generation, transmission represented there, of course, wastewater, manufacturing, it goes on and on and on. And we have already analysis centers, places where information goes to be shared. And in our process over the last short period of time, just during this year, as we've gone through the mental exercise of creating the ICS ISAC, we've learned a lot more about the state of this. And one of the things I'm here to tell you is that it's actually very good. I know there's a lot of angst. We have, not to get into any specific cases, but there are entities that would like the utilities information, for example, that the utilities may not want to share with. And it's not a mistake. It's just where we are in time. If we go back 10 years, the public analysis centers were all that existed. 10 years ago, most of us and most of the companies we work for wouldn't put the resources into it. There wasn't the reason for it. There wasn't the cost benefit. It was more of a burden. And what's developed over the same period of time is a broadening of that space, where you have private analysis centers that have arisen for various reasons inside vendors, because they want to be seen as a center of information, with the public-private analysis centers, where the government is trying to reach out and create some sort of forum where people can be more comfortable to share more information. And this ecosystem is developing a lot. One of the analogies I find myself using in this space is we're in this room. I can't see any of the rest of you, but I imagine we're all sort of an age where we remember 3 channels of television. And then, as Bruce Springsteen told us in the 80s or 90s, wherever it was, 57 channels and nothing on. We started to get lots of channels, what felt like a lot of channels, but it didn't get any better. Similarly, in the information sharing and analysis ecosystem, many people who've been involved in it over the last 10 years see a proliferation going on, but it's 57 channels. And my point during the proliferation of television channels was not that 57 was too many, it's that 300 is too few. And I don't know if the rest of you have cottoned on to Netflix and so forth the way that I have, but we now basically, from a media perspective, have a billion channels. And that actually works. So now you can actually find something to watch when you want to watch it. Similarly, in the information sharing architecture, we need lots of centers. Just in the public analysis center domain, we don't just need one place in this entire country to share information at the government level. That's the federal government. We also have 50 states and 5 territories, and we have inside those states. I live in California, where the folks physically there are gathered, which has a bigger population than Canada. One center of expertise and one center of information sharing really doesn't address all of even California. So in the public analysis center space, we see that expanding from the federal to the state to the municipal level. We'll talk a little about that. In the private analysis center, we see that expanding with some of the nonprofit privates that have been around. Some nonprofit privates are being started right now. And the public-private, the ISACS ecosystem is 14, 15 years old now, and it's really just, it's just going through puberty, perhaps, is one way to say it. So to get information back and forth to these centers, it has to come from the people who are actually using the systems. So if we look at that exchange, we've got to have at least 2 things. We have to have some anonymization of information going upstream. Certainly, the centers themselves don't really need to know all of your MAC addresses, all of your IP addresses, every single thing that happens on your network. And quite possibly, depending on who you're sharing it with, you may not want them to know that. You may not be comfortable with, or you may just outright not want to, or you may not legally be allowed to give them that information. So we have to develop a system so that we can anonymize, pretend to anonymize metadata. Not that this, this utility, a co-op in rural Alaska, had an incident, but that an entity of this type had this type of experience. And again, to have that balance of cost and benefit work out, we have to have some value-added information coming back to the utilities and down to the facilities. Something that makes their lives better, cheaper, faster, lower risk. And that's working its way through. And then, of course, between the information sharing centers themselves, each entity in this information sharing network we're making has different needs. The public Can you hear me now?
Yes, Chris?
Hi.
Hello.
Hello. How's that working now?
It's working just fine. Did you lose your audio?
Yeah, it dropped the call for some reason, so I'm reconnected.
Okay, yes, your Skype connection. All right, go ahead.
Okay. And I can't help saying, but we used to be able to communicate well, but now we can communicate bad in a million ways. Anyways, so we're broadening broadening the space. So the information analysis centers need to communicate with each other certain ways. The DHS, for example, has legal guidelines that don't let them share information certain ways. A private analysis center that's working with utilities and entities may be under a diligence responsibility to not share information with certain entities, with public entities or regular entities. So, but that whole ecosystem is filling out relatively nicely. And then when we get into the very large numbers of utilities, this direct relationship between a facility and an information sharing center probably isn't going to really scale. Okay, so we'll come up with some sort of aggregation centers. I just got to note that I'm breaking up a little bit, so Irfan, please step in if my audio gets too bad here. So this is the architecture, one way or another, that we need to create. There doesn't seem to be any way around that in our conversations with DHS and with the people who've been building these centers. There seems to be common agreement that however we do it, we're building an architecture that looks like this. So let's drill down a second into the sharing centers, because this is a lot of the architecture that we have today. And that we build everything else around. So we have public sharing centers, we have private sharing centers, then we have the public privates. And again, 10 years ago, we really tried to have public sharing centers that were everything. And that won't scale, so we're now building that out. So the public sharing center, we have a lot of different organizations, and we really have something to stack. This isn't really top-down, but we have the Department of Homeland Security and all of their interests. We have stated through ISACS, for example, the Department of Energy, Department of Defense, the EPA, and again, as professionals, as we spread out beyond the electric sector, we find that the water sector is perhaps a bigger problem. We'll deal with that. The regional entities, the Southern States Energy Corps, as an example, is a collection of the 16 governors in the Southeast states that set certain rules, and they have an interest in information sharing in this space. At a state level, California, Arizona, each individual state has a responsibility to citizens, and it needs to both have their own continuous awareness as well as be able to propagate that and ensure that their constituents have it. Breaking down farther and farther, the National Association of Regional Councils, NERC.org, is an organization that I didn't know about a year ago. This represents all of the local governments. The county government get together in groups. My group is the AMEC group, which is the Association of Monterey Bay area governments. And down to the county, down to the municipal, Hudson Valley, my little town needs to be able to know what's going on. So the public space, when we look at this, is at the federal level on the left, at the regional area, and then the stack down from the state down to the municipality. The commercial, in the private space, we have commercial sharing centers and non-profit sharing centers. Each of these has their own constituency and their own purpose for being. We see with IBM has X-Force, Intel has a global threat intelligence system. We have vendors with different systems, and we have non-profit entities like SCADASEC. I think a lot of us are probably all members of SCADASEC and have been for a long time. EnergySec is standing up, or has stood up, a tactical analysis center, which is a bit more like the analysis that goes on in ISACS and other systems. So we get this sort of thing balanced out in the private space, private for-profit, private non-profit. Each one of these serves a very valid purpose. No one but the vendor would necessarily have the breadth of experience and the depth of penetration into the customer space and the trust levels with their customer and their deployments. However, the private for-profit has a certain intention that enables some communication and disables communication. private nonprofit doesn't bring those hindrances to, and also does have some of the relationships. So no one of these entities will necessarily be key. So Irfan, before I dive into the ISACS, I just want to make sure my audio is working okay. I've seen a note that I'm breaking up a bit. If you can ping me a note. But I'll assume you can hear me in the meantime then. So the audio is pretty rough. All right. All right, Irfan, I'm going to try to go to speaking slowly. If you can hear it breaking up. Damn. All right, we'll do what we can. We're sharing information. This is a great analogy for how it's actually working in the real world. So, ISACS. These systems, these centers were created under a presidential directive under Bill Clinton in 1998. In 2005, it was re-upped under George Bush. And over the last 10 years, particularly, there's been a lot of exercises in creating these individual public-private information analysis centers. Yeah, no, unfortunately, it's not Bluetooth, and it's just, I think the island of Nassau only has the two ones to share with the outside world. So we will do what we can. I have plenty of bars. I should, in theory, be able to communicate. So the ISACS to the energy sector, the electric sector, ISAC, we're all probably familiar with in this context. It's been around a little while. It's recently been restored or updated. The financial sector, ISAC, has been around for a long time and is one of the fairly well put together ones. Then a number of different vertical demographics. Frequent interruption. Chris' audio. I want to say, guys, I will follow Irfan's lead if he would like me to change modes. Brad may be able to follow through this since he is in mainland U.S. I can comment a back end. So Irfan, let me know how he takes that. All right. So the ISACs have developed a vertical structure. And when you look at it, you realize there's several horizontal structures in that as well. The IT ISAC, well, everyone uses IT in their business. The MS, the multi-state ISAC, is a different type of horizontal that bundles all of them together for geographic purposes. And the ICS ISAC is being stood up to capture commonalities in industrial control system cybersecurity found among the sectors and transport those effectively across sectors. The REN ISAC, the Research and Educational Network ISAC, whether you folks can hear me well or not, this is a good place to go to get a feel and understand the ISAC structure. The REN ISAC is very robust. I stole this image from their page because it's a good representation for the kinds of issues we need to look for. You know, watching for things, blocking for things, having high confidence, hiding information, sharing appropriately. And this is, I guess, from all this part of it, the thing I would want people to take away is that this structure, the ISAC structure, is actually developing very well. I have very high hopes that over the next 12, 24, 36 months particularly, we'll be able to do things in the public-private sharing space that really hadn't been possible in previous years. But it's because people have put a lot of effort in building these individual columns, these individual pillars. And it's not that there's been a great deal of failure, there's been a great deal of work, there's been a great deal of education we all learned along the way. So the ICS ISAC as an example as we get into this, as I say, it's a horizontal that ties things together, collect and transport commonalities. Having ISAC to ISAC communications through the National Council ISAC, there's a bit of this going on now. We believe that we can automate a lot of that, so that as commonalities are found in the electric sector, they're automatically transported to the surface transportation sector, for example. And as each of the ISACS deals directly with constituents as well. So multiple directions of information sharing in multiple ways for multiple entities. So Irfan, I hear my audio's gotten better, but I'm going to limit this part of the talk so we can have more Q&A and don't rely so much on the internet.
Yes, it is a best effort protocol, and you don't get anything for free.
Apparently not. I hate for this too, the bastards. So to talk about what you have to have, if you're a facility and you want to partake in these information sharing structures, you need to have certain capabilities. And if you have no information, you can share no information. And if you don't have certain capabilities, there's not much you can do with information. And this is one way to look at it. You know, I'm a SIM person, so I tend to talk about SIM, but it's really not just that. SIM is just a dashboard. But there is a contiguous set of functions, of capabilities, that if you have these all together, they're really all called for by one sort of regulation, one sort of best practice another. They have the ability to have a reasonable view of what you have and what it's doing. If you have that view, odds are good that information you have will be worth sharing, and that when people share information with you, odds are good you can do something with it. So I'm going to skip a little slide here just to keep our stuff straight. So the LIGHTS program is a nonprofit, non-commercial effort put together with NERC and a number of other organizations, Rochester Institute of Technology, Trust and Metrics, and others. It's being launched officially next week with the support of a lot of the industry and government and so forth. And it's interesting in this context because it's an example of these structures. So it's a membership organization, so facilities can become members, get all benefits from that, and we'll unfold that at better audio times. But it's a good example of this whole stack I'm talking about. So at the facility level, with LIGHTS program, there's a sensor on a span port watching traffic and doing very little else, but it gives visibility so that you have that basic capability set at the facility. With that, you can share information up through aggregation centers, in this case, they're MSSPs, up to the analysis centers, and back down again. You'll see that this architecture looks just like the one I started with earlier, with the exception that there's no direct connection now from the facilities to the analysis centers. So LIGHTS is a program to aggregate the hundreds of thousands of small facilities into the information sharing architectures. So to put a cap on some of this, being informed is key to being secure. I mean, if you don't know that you have problems, you still have them. And in a group like this, we've all heard it enough, but the threats are very, very real. Attacks are scaling massively. As particularly in the small entities, I know the people that we talk to, quite a lot of them feel orphaned. They don't have information. They don't really know what's going on, and quite often they'll assume that doing nothing is their best approach, and that's really not going to work really well. The information sharing architecture is evolving. That as we've looked at this ecosystem over the last year, we find a lot of hope where a lot of people find despair. The centers that have been set up and the efforts, even the efforts that have failed, have been set up with good intention by smart people, and we've all learned a lot of lessons from them. And with the blocks that have been built that are in place today, we have a very strong ability and opportunity to go to the next level, to achieve as a community what we've almost lost faith in. So, Irfan, given the audio issues. Would you like to take this into a panel discussion at this point?
Okay, so thank you, Chris, for the presentation. And what we are experiencing from your end is sporadic disturbance in the audio. But when it comes clearly, it's very, very clear. So I think it's just your internet connection. I have to say to the folks on the webinar and here in the room that Chris is actually a local person, but it just so happens that this date coincided with his 25th wedding anniversary. So he's actually on vacation in the Bahamas, and he's calling in from there because he thought this was so important. And it takes 25 years of marriage to get a spouse to be so understanding as to be able, so you practice in the 5th and the 10th and the 15th. So by 25th, they're like, yes, go ahead, honey, do your presentation. So I have to applaud your spouse, Chris, for allowing you to do this. But it's a real privilege for us that in such a special time in your life, you've come out all the way from the Bahamas and presented here. So taking a little bit of the audio disturbance is not the end of the world. So I really appreciate it. But what I'd like to do is bring up the Q&A window of the webinar to see if there are folks on the webinar who have questions, and we can get those answered. And then folks here in the room will come up to the speaker phone here and ask the question directly so that the people on the webinar can hear also. So at this point, what I'll do is go and look at the Q&A and chat window. Okay, I don't see any questions in the chat window. I'm going to now look at the Q&A window to see if there is any possibility for questions. I don't see any questions yet, so for those of you who are on the webinar, if you could post some questions for Chris. And are there any questions here in the room? If so, if you could come up to the front and ask Chris directly, that would be appreciated. We have a question here from Jerry Lamble who says, how to find research opportunities. Chris?
I'm sorry, can you repeat that? How to find research opportunities in this area. There's, in our research into the field, we find a lot of centers. I'd be happy to connect anybody here with a number of them. It's one of the things of the time is that when we stood up the LIGHTS program and made a web page with all of the information sharing centers we could think of, we heard from the U.S. federal government that everyone's using that as a reference page because no one had really called all that yet. So you can Google, you can look, you can ask us, we can connect you.
All right.
Now, and that really, it really is exciting times. I mean, now for those who want to get involved with this, it's, there are times when you build things, there are times when you join. Now we're building, and I think it's a lot of personal value for professionals who want to get involved, and a lot of organizational value for entities that want to be involved now.
Thanks, Chris. We have a question from Edwin, who asks, what is the information that should be shared? Be specific as to the data or sensor output that is needed to be shared.
Sure. So if I'm taking this as a utility up question. So as a utility, you have all of the information. You know You may not. Let's start there. So if you can't tell from a cybersecurity perspective what you have and what it's doing, then there really isn't much to share. And honestly, this is a situation a lot of facilities have found themselves in to date, where someone externally will come out and say, you know, we want information A, information B. You want to be in the position to say, here's the information I have. Here's the information I'm willing to share with you. And the specifics, things like that, you know, between a utility and the federal government, for example. The federal government does not need to know your MAC address. They don't need to know the specifics of what happened. What the federal government really needs to know is things like 17% of electrical quotas were all hacked last week. And it was
can you repeat that? It got interrupted with the Skype.
Sure. So what the federal government needs to know is not the details of your operation. The federal government needs to know that last week utilities were attacked. So to answer that, it needs to know who's sharing what with whom. But from a facility perspective, you should always take a conservative approach, that you own your information, you know what you have, and you know what you're willing to share. Otherwise, you know, you find yourself trying to answer other people's questions.
All right, thanks, Chris. There is a second question from Edwin, who asked, what specific information can the aggregator share back with the industrial site that is actually useful to them?
Sure. So things like, and there's the positive and negative information. There's the information like, you know, a best practice that members either of that aggregation network or from higher levels of information sharing, that best practices have been identified that are worth knowing at a facility level. That's a positive piece of information. A negative piece of information might be that, you know, half of your peers have been attacked in a certain way yesterday, and you may want to watch for that, or you may want to put mitigations in place. You may want to prioritize your mitigations and put something at the top of the list because this is becoming a popular attack.
All right, and then Gina asks, hello, thanks very much for giving this presentation. I'm very new to this field, have an environmental background, so I have a very basic question for the layperson. What references would you recommend to get up to speed quickly? Thanks and regards.
Well, that's a big question. There's some good books out. Mike Eccles put out a good book on grid cybersecurity just recently. There are good discussions in the LinkedIn groups. There's a number of good discussions where people are talking about these issues. And there are some courses out there, but without judging anyone one way or the other, my general impression is that a lot of the courses are a little bit dated.
Yes, and there are several documents that are coming together through the NIST Interoperability Roadmap Project, which are a good read. Some of them can be quite technically in detail, but I think the introductory sections of the Interoperability Roadmap presentation or paper that came out, I believe, in September of 2009, and then the NISTIR 7628 document that came out in 2010 are very good primers for both the concept of interoperability and security. And as Chris is showing to you, those two concepts have to really come together, because it is really having situational awareness across multi-vendor technologies that's going to be very important in maintaining end-to-end security. you could meet a requirement, and I'll be talking a little bit more about this during my presentation, that you could have very robust security at an interface level, but then when you look at the whole ecosystem as a set of systems that are interconnected, the hacker is going to look for the weakest link. They're not going to go after the challenging algorithms for confidentiality on interfaces that have it. They're going to go for places where there are inconsistencies or where there is just an oversight on the part of the designers. So having knowledge from documents like the NISTIR 7628, having knowledge from the NERC CIP guidelines on critical infrastructure protection, you can read the introductory sections of the various CIP guidelines are quite easy read. You don't have to get into all the bureaucratic detail, but at least you will understand what types of things need to be in place for bulk power systems to be secured. So I would recommend those two. I think the book that Mike Eichels of PwC has written is also a good resource. And then there is another book by Andres Carvalho on smart grid, which I think is available on Amazon, so you may want to check that out. You have a question here in the room. Could you please identify yourself and ask Chris the question?
Hi, Chris. My name is Pat Fasang. You might have mentioned this, but maybe I was distracted by the audio problem. The question I want to ask is, what does LIGHT, the acronym LIGHT, what does that stand for? And second, can you please briefly explain the essence of this program or this acronym? Thank you.
Sure. And I'm breaking my own rule with this because I've sworn to give a different answer every time. The acronym really doesn't stand for anything, but it could stand for the large initiative to gain high-tech security, or a lot of things. But the program is based on the several ideas. One is that there are far more small than large utilities and other facilities, and that we have to find a way to address them. That addressing a small facility is actually quite easy, and it's consistent. It's very similar. If you do one electric co-op, most other electric co-ops are very similar. Most small facilities, whether they're water or power or other, tend to need the same things. So as a nation, we have a need to get beyond the big iron approach and find a way to address, is really 99% of the problem, which is small facilities. So the program is created as a nonprofit, non-commercial membership organization to, as much as possible, remove the biases and just say what is the best solution. And it is biased to a certain extent because those of us who built the program believe that situational awareness is the low-hanging fruit. Can't necessarily.
I guess we lost the audio again from Chris. All right, so I think that what we're going to do now is move to the second presentation. There are still a couple of questions. We'll come back to them. There was one question on Joe Weiss's book, if that would be recommended. And I think that with the experience that Joe has in the industry, if he's written a book on it, I haven't read it, but I'm sure that it will document a lot of use cases and incidents that and the mitigation that is needed. So it's not bad to check that out too. And then the question from Edwin, one of your slides you showed a PLC. What specific PLC created information would be worth sharing with the aggregator? So we'll keep this question for Chris until Chris comes back.
If you can hear me, I'll try it.
Oh, okay, Chris, you're back. So do you recommend Joe Weiss's book, and what is the PLC deal?
Joe's book is good. You know, it's a bit thick. It's more of a reference manual than a read. And the PLCs, well, PLCs are part of a network, and so the information that's worth knowing about those are what they're doing in relationship to everything else. As a device, you know, are there vulnerabilities on it? Are there overlooks? Is it doing stupid things? Generally speaking, it's a very good point because we focus on the PLC so much in this industry, and it's one of the hardest things to fix. And it's not so much about fixing it; it's about knowing what the risk associated is, and then watching for that risk.
Very good. So thanks again, Chris, and we are going to move to the second presentation, and then we'll have a break. So at, I would say, 6 p.m. our time, which would be 9 p.m. in the Bahamas. So maybe you can get a bite to eat in between now and then.
Absolutely. Thank you, Irfan, folks. I'll be back.
All right. Terrific. Thank you again. Sorry for the noise. And coming back to the second presentation, let me just say a few words before I start. Cybersecurity is definitely getting a lot of attention in the United States and internationally around the electric sector. And the main reason is that a lot of people from the information technology side have suddenly realized that there is a power system and it has information technology that needs to be secured. It doesn't mean that the power system side of the business was asleep at the wheel for the last 100 years. They have been securing their systems with the limited technologies that existed in the field to take care of the communications that they were involved in. But what has happened in the last 15, 20 years with the advent of modern communication technologies is that increasingly the power system's networking capability is growing. And it is growing both in the individual components in terms of the bandwidth that can come to the device, the memory, the processing capability on the device, but it's also going out farther and farther into the electric grid, starting with the network operations center, going out to the substation, and now going beyond the substation into the distribution network. Put that with the deregulation that is occurring in the electric sector, where there are so many entities now that are involved in the supply of this electricity. The entity that produces the electron is not the entity necessarily that delivers the electron to the customer. So when you cross all of these domains geographically with applications that traverse across these domains, securing it by having all these different stakeholder groups involved is not an easy feat. And so that is the big paradigm shift that is occurring as this industry is getting deregulated, is that suddenly we have gone from a single trust system where you put a big wall around the outside and you pretty much consider the inside the trusted system. You can't use that model anymore. Now think about the complexity of the business models that are involved. Not all the parties that are going to be involved in this supply chain from the power plant all the way to the consumer have the deep pockets to make the investments that are necessary to secure the communications. So you will be dealing constantly with a tension between delivering the application and making the proper investment to secure it so that it is safe and reliable for a long period of time. And in the absence of funding from external agencies, if everyone is left to their own, no pun intended, devices, you know what's going to happen. It's going to be very difficult to have the minimum security guidelines in place. So while the documents exist from NIST and NERC, and DOE is coming out with their requirements, those are all theoretical exercises until there's an economic model that will work so that all the different stakeholder groups feel empowered, are informed, and they have a deployment plan. So there are many stakeholder groups that are involved in cybersecurity today through collaborative work. One such effort is the NIST Cybersecurity Working Group. That group has 5 subgroups that involve design principles and architecture and standards and privacy and so on. There is an organization called the National Electric Sector Cybersecurity Organization that is a collaborative forum for sharing information about events, incidents that occur, so that vendors can figure out how to mitigate the risks from those types of threats. So that's the NESCO, the organization. And then there's an R&D compendium to that called NESCOR, which EPRI is leading with several other business partners, and that's the R&D arm of that. So this is the DOE effort that's going on. And then there are various working groups that NERC, the Organization of Regulators, is also working on the issues of, for instance, data privacy, because all this customer data is being generated from smart meters and from home area networks. The question is, what are we going to do with that data? Who owns it? Who has rights to it? What happens if that data is stolen? Those kinds of things. So there is NERC that is doing the work. And then there is a trade organization called Utilities Communication Architecture International Users Group, UCAIUG. And you can go to their website, ucaiug.org. And within that, they have a group called OpenSG. And OpenSG has several of the large utilities involved in its membership. They have vendors, they have integrators, and they also have a variety of product vendors who are involved in this. So this group is coming up with the requirements for securing the different parts of the smart grid. Now, 3 years ago, when the NIST Interoperability Roadmap project started, we had 7 domains defined in the smart grid. And those domains, they were the electrical domains that involved generation, transmission, distribution, and end use, where they were all connected by an electrical wire and some communications. And then there were 3 other groups that were defined. One was the energy markets, where the trade occurs on energy. There's the service provider folks, the ones with the trucks that roll out and fix things. And then there was the operations. So the operations is where the NOCs are and where you collect the data from SCADA applications and take corrective action. So these were the 7 domains. Now imagine the elaborate communication links between these 7 domains. They have application layer things going on. They have semantic layer things going on. They have object models that they exchange data with. Then there's a comms layer. There will be either TCP/IP or some proprietary networking technology. And then there will be a variety of physical and medium access control layer protocols in each of these domains. So you can think of this logically as having layers. And then you can think of these domains as being geographically sometimes hundreds of miles, sometimes it could be the building next door. So you can think of what a mosaic there is of these different protocols, the different layers across these domains. Now, when we are talking about cybersecurity for something as complex as this, you're not just simply saying, I'm going to encrypt and I'm done. And the reason why is because quite often a hacker will compromise a trusted system. And then the encryption engine will encrypt their hack along with the data. So encryption is a good technology to avoid man-in-the-middle type attacks and the usurpation of data. But it's not a cure-all. And a lot of people have equated cybersecurity to confidentiality. Whereas in the electrical system, availability of the electricity is the #1 priority. Getting a read from a substation with a bunch of zeros and ones doesn't really matter. That's not privacy. Privacy is where, the customer is there and the smart meter and the home area network data. Yes, you need to encrypt that and store it properly. But the data that's inside the electric grid itself, those zeros and ones mean very little to people except to those remote terminal units or other intelligent electronic devices so that they can perform properly. So their availability of the network, getting the data to the right device so that it does the right thing, is more important than the actual whether someone got the read or not. And the integrity of that data is very important. Because if there's fuzzing going on the data, and that causes malfunction of the devices, that is worse than the usurpation of that data. Because what are you going to do with a bunch of zeros and ones if you don't have physical access to that device, or you don't have logical access to the device and you can control it? Just siphoning data is not an issue. So this is a complete paradigm shift from the IT mindset. So the CIA needs to be looked at AIC. And there is a lot of challenge there in how we are solving these problems. So I wanted to give you this preamble because cybersecurity is a very complex concept. It's not just application of certain technologies. It involves technologies, but it also involves human beings and training them properly so that they are more security aware. And then there has to be a regulatory framework around that that is conducive to protecting those assets. So that's why if you see the NERC folks are so involved in this, because the state's regulators are the organizations that set the policies, and then the vendors will produce the products that are in line with those policies, and then the integrators will implement it, and then the utilities can work with it, and then the customer gets their electricity. So we're all connected very much at the hip here. And cybersecurity is this overall thing. I usually try to call it like Zen, it's like nirvana or Zen, because you get to a state, but it's not something discrete that you say, okay, now I'm secure. It's a set of practices, it's a set of technologies, and it's a set of business processes that need to be in place. So this preamble is to open your minds. There is a simultaneous class going on with this webinar. There's a Foothill College Engineering 83 class, and I am its instructor. So this is a virtual class going on. So there are people who are on the call and in the room who are taking this class, and they're auditing the seminar so that they're learning about what kinds of issues are there in cybersecurity. Also, it's a big mistake to separate network communications from cybersecurity. Quite often in organizations, you see that. You'll see two different communities. Occasionally, they'll have lunch when their managers ask them to. But we need to get a little more friendly across those lines. And the reason is that availability of electricity in a highly controlled grid, think about it, requires communication networks. So if availability is a trait of cybersecurity, and in order to have availability, you got to have a communication network, doesn't it make sense that the two should be looked at in conjunction with each other and not as separate things? So like SNMP, Simple Network Management Protocol, has community strings. Who's responsible for that? in most organizations, the networking people have a guy who thinks he's cybersecurity savvy who maintains those community strings. You ask him, what are your firewall policies like? He says, hey, that's not my business. That's the security folks. I just make sure that these SNMP community strings on the routers are kept with me and updated and all of that. This is what I have seen out there. So we got to be real. You know, it's not going to work like this, especially if these routers are increasingly being depended on to carry power systems communication. Think about that. Previously, a lot of the grid had not routable protocols. They had serial interfaces. A lot of the DNP messages went without any need for routing. But that's all changing. Companies like Cisco and Juniper and others are getting into the middle of this. They're providing that network layer in highly routed networks. Quite often, if you go through the NERC CIP guidelines, you will see for routed networks, follow this. For not routable protocols, follow this. And you see that in the NERC CIP. CIP stands for Critical Infrastructure Protection. So we have a very interesting situation where a lot of technology has been thrown at the power systems, but we are still not very organized from a human perspective, from a division of labor perspective, and how the various groups work together in order to provide what I call network systems management, which is really a collective noun of network security and network communications and network management, all of it together. And there is a move now within the International Electrotechnical Commission to develop a set of objects for network systems management, so that no matter what the vendor is, and no matter which domain they're applying their devices in, that there is a semantic layer, a vocabulary that they can understand for their domain, and they can exchange information. And that will give rise to a whole new level of interoperability that doesn't exist today. So keep that in mind. All right, I just have 3 slides, and then we'll go into break. So my preamble was needed just to open your minds to possibilities. So one of the challenges is that we have these legacy systems that have been around 25, 30, or even more years. They did their job. They provided the connection between a network operations center and those remote terminal units, those digital fault recorders, digital protective relays, capacitor banks, and so on. And those protocols, in many cases, were running on a serial interface, which is not like a TCP/IP-based protocol. It's much lower level. But it did the job. The response time was reasonable. It was in clear text because it was all in one domain. Now, with all of this information traversing multiple domains, there's the need to encrypt. There is authentication that is needed. That means putting passwords and things like that. And there is the need for having some kind of authentication that is beyond password. They're getting into, you know, the biometrics and other things. All of this requires CPU, it requires memory, and it requires bandwidth to carry this information back and forth to those authentication engines. And so if you think about it, these legacy systems that were not designed for all of this sophisticated technology are now facing these new requirements. Some of those requirements in the bulk power system are coming from NERC, the National Electric Reliability Corporation, which has been authorized by FERC, the Federal Energy Regulatory Commission, to set a set of guidelines, and then there are essentially audits of the utilities to make sure that they're meeting those. So if there are legacy systems, they need to be secured. against those. And in the general smart grid, if you look at the NISTIR, NISTIR 7628 document, there are a set of requirements for cybersecurity at the interface level. You'll find a spaghetti diagram. Spaghetti because there are a bunch of noodles that came out of the use cases that showed which actors transacted with whom, and each one of those became a noodle. And now the whole thing collectively looks like a spaghetti diagram. And somebody is going to throw some ragu sauce on that spaghetti diagram very soon. And so to avoid anyone throwing ragu sauce on the spaghetti diagram, you have to look, and this is where I now move to my next slide here. What are some of the problems that we're facing? So I mentioned that legacy systems have limited memory and processing capability. The networking technology could be quite rudimentary that's associated with it. And that's simply a function of the time and the business need of that time. Today, they're not able to meet that in certain ways. The NERC CIP and the NISTIR are two guiding documents that a lot of utilities are using to come up with cybersecurity requirements. The NERC CIP, remember, is just for the bulk power system. It's not applicable to distribution systems. The NISTIR, on the other hand, applies to all the domains, and hence that spaghetti diagram that I was telling you about. So some of the requirements for authentication, like the password requirement, and then the encryption, level of encryption that you need that cannot be compromised, and NIST maintains that level of encryption at all times and says you need to be this or better. So when you look at those legacy systems, in some cases they're not able to meet that requirement. So what ends up happening is that utilities have what is essentially way out of that situation through what's called the technical feasibility exception, and that's the TFE. And what the TFE is it's saying, look, you know, it reminds me of the story of Noah, Prophet Noah, that when he landed with his ark and all the animals were with him, he asked all the animals to go forth and multiply. And so two snakes approached Noah and said, Prophet Noah, tell us, how shall we go forth and multiply, for we are adders? And so Noah thought for a little while. Then he went and he cut a big tree down, and he stuck 2 pieces of wood on either end of it, brought it to the adders and said, here's a log table, now go forth and multiply. So TFEs are a lot like the log table that will allow adders to multiply. So what do I mean by that? I mean that if you can explain, I'm talking about things like printers, for instance, that are networked. A lot of times they may not have the capability to have all the authentication and encryption technology put on them. So utilities are able to file for a technical feasibility exception saying that in certain circumstances, I am not able to meet XYZ requirement from NERC CIP, and if approved, it doesn't mean that they can just leave it as unsafe, but they are not going to be penalized or being out of compliance as a result of that device. But until that TFE is approved by NERC, there's a possibility that they're not in compliance. So it's a very, very delicate process that they have to go through. But the problem is that even if the technical feasibility exception has been ratified or approved by NERC, it doesn't secure the system. And if a hacker finds out that there is a certain exposure as a result of that TFE, and they can exploit it, then there's a problem. So what a lot of these organizations like the NESCOR folks and the CSWG and NIST are trying to do is go beyond the TFE and saying, how do you mitigate the risk associated with legacy systems that have been given the TFE pass, but are still vulnerable? So this is the gist of what I'm trying to speak about today, is to challenge your minds to start thinking about, I have some primitive technology that's doing the job today, but the tomorrow that I'm describing in the highly networked grid is not going to allow me to do that in a secure manner. So what modern technologies can I apply to these legacy systems so that the security is in place along with compliance? The forklift upgrade concept, which has been used a lot in enterprise IT to meet business needs, is not so easily applicable in power systems. It would require hundreds of billions of dollars. I feel like Dr. Evil from Austin Power saying that. But that's basically what it would require. And what would happen at the end of it? The hackers would find the next generation of vulnerabilities on the modern systems, and then the problem will go on and on. So the answer is not to just say, just gut all of this non-IP-based stuff out and stick in modern systems that run TCP/IP and run TLS, and you're done. Not so. The TLS does not address, and we have, I feel like, I'm giving a talk and experts are sitting here in the room, but I have to say that the FiMac layer has been neglected a lot. I'm talking about the physical and MAC layer when it comes to security. There's been a lot of momentum towards application layer security, encrypt, authenticate, and all of that. But a lot of times, the operating system on which the application resides needs to be looked at for vulnerabilities. And in the communication stack, the physical and medium access control layer needs to be looked at. And I have seen some of the work from IEEE P2030 that addresses some of those issues. So we need to focus on that, just like we need to focus on having a VPN with encryption in the network layer and having the TLS type security at the transport layer and application layer security from the different vendors. So all layers are important from a security perspective. We have to have an overall view of it. So when we talk about forklift upgrades, they're not the answer, even if we had the money. All right. So what are some of the possible mitigations? Some of the possible mitigations include what are called bump-in-the-wire type security technologies. So, for instance, if you had a legacy system, if you remember, any one of you who's been in networking 15 years ago or 20 years ago, you remember mainframe computers, the old IBM computers and the PDP-11 and all of those old systems? They didn't have Internet Protocol in them. But what started happening about 15 or 20 years ago was they started encapsulating the mainframe data in IP packets and transporting them across the wide area network to another handoff point where the IP packet was stripped and the payload was delivered back again into a non-IP world, hence the mainframe. And to avoid a lot of the chattiness back and forth over the wide area network, they used to do what was called local spoofing. So essentially, you had a system that would talk back to the system that was sending it, and to the system sending it, it thought, oh, my recipient is right there. And they would talk back and forth because the protocols were chatty, because the networks were very dirty, and so they needed that constant assurance. Yes, I'm there, I'm there, I'm there. Don't worry, I'm here. Oh, did I tell you I'm here? So that's the kind of stuff that was going on. So X.25, if you remember the protocol that preceded TCP/IP, had that kind of chattiness. IPX from Novell had that chattiness. But IP kind of toned it down a little bit. So these technologies, the bumper and the wire, what they're doing is they're providing that TCP/IP engine with its security features in them between the legacy systems. So the legacy system doesn't have to have the latest and greatest technology on the device itself. It hands it over to this encapsulation engine, runs it across with all the encryption technology that is needed to the other side. So these are some of the ways in which you can get around the issue. Because then you would have to have physical access to the actual legacy system in order to compromise it. Because there it would be clear text since it's older technology. In some cases there may be rudimentary encryption technology, but it may be compromised, like DES, has been compromised. So if it could only handle DES, it's as good as not having encryption, because the processing capability of hackers has gone way up, so they can break through these protocols. Okay, Gumstick. Gumstick is something, it's actually a company, and they sell, and there is, I believe, Texas Instruments and Marvell chips. Maybe, David, you can talk more about this at some point. But this particular, it's like having a mini computer, and it has a Linux kernel on it, and it's used for a variety of applications, including cybersecurity. So what they have, I've seen a demonstration of this by Sandia National Lab, and I believe N-Dimension has a very nice demo of this also. They showed it at DistribuTech. I remember that. That they'll take a legacy system and they will literally stick the Gumstick on the legacy system physically. And it gives all the latest, greatest networking technology, the crypto engine, the authentication to the legacy system without forcing the legacy system to have it indigenously. And this is the equivalent of that mainframe analogy I was talking about 15, 20 years ago when you had that IP handoff point. So today, with this miniaturization from Gumstick and companies that are using this, so essentially they'll take the mini computer and they'll put all kinds of cybersecurity technologies on it and test it with different legacy systems. I think that there is great potential for utilities as a buying time kind of thing until the end of the life cycle, so that when they go for the next generation system for their power infrastructure, then they can go to the more modern systems. But this buys them some time. And then the third bullet is something very few people think about, which is that if availability is a critical part of cybersecurity, doesn't it make sense to think about how we can optimize the network itself so that we have more resiliency in the system? Now, the difference between security and resiliency. So security is kind of like a barrier that you're trying to put, or trying to stop the hacker from doing stuff. Or a system error, like, if a system does something, so there is some way of verifying that it's doing it right, and if it's not, it'll try to stop that process from going through. So all of that comes under cybersecurity. But resiliency is the ability for a system to be compromised but continue functioning, even in the degraded state. And having the ability to recover from that degraded state limits the influence of the entity, whether it's a hacker or a system, from doing further damage, and digitally recording what it's doing so that they can be prosecuted in the future. All of these things are important. See, I'm talking about the operational side of this business. We're so busy trying to implement everything, put systems, connect, wire, all kinds of jobs doing that. But what happens the day after? Those are the kinds of things I'm talking about, and they're the ones that, if addressed properly, will provide electricity in an affordable way for a long period of time. So in re-architecting, what I'm talking about is there are some situations where redundant paths will help in resiliency. So if one leg gets compromised, the other one is still working. A lot of times you may want to have taps, like fiber taps, and you are monitoring the network from a place that the hacker cannot see. So those kinds of things are helpful. So we need to start thinking about how electricity flows through the network. How can we create redundancy in both the electrical wiring in the distribution network and in the bulk power system? And how do we create redundancy in the network infrastructure, the networking infrastructure that carries the data to control them? So both require a rethink of how we can do that. And those types of things can soften sometimes the cybersecurity requirement at the interface, just enough to meet the requirement. For instance, I'll give you an example. When I was in the NESCOR project, we had a project within that, a task, to look at the TFE issue regarding passwords, because there were legacy systems that required, I believe, 6-character password requirement from the NERC CIP. But the problem was that it took less than a second to compromise those 6-character passwords. So the question was, you go through all this trouble to try to meet the requirement, and then in less than a second, someone can compromise it. So the question is there a way to revisit that, maybe in the next version of NERC CIP, so that we understand the pace of technology? So at this point, what I'll do is I'll open it up for any questions, because I think that's my last slide. Yeah. Some of these critical issues that I'm going to leave here, one of them, of course, is availability. I've already spoken about that. It's critical to power systems, and it will trump confidentiality in the middle of the grid. I'm not suggesting that for the edge or wherever there's customer data, because that's where confidentiality is critical. Compliance does not assure security, just like an accredited school does not guarantee a good education. You meet a certain set of requirements for being in the right zip code, but you're still not down the right street or the right house to say, I'm home. So the security aspect has to be seen in parallel with compliance. You meet the compliance requirement, but continue the argument until you have some reasonable level of assurance that against the known threats, you have some kind of mitigation strategy in place. This is a very important thing. When we do use case analysis, and they have come from Southern California Edison and EPRI, and they've been collected in the interoperability knowledge base of NIST. You can go to their website, nist.gov/smartgrid, and you can go into the IKB. You'll find a lot of use cases. What use cases do is they describe a narrative of actors working together, transacting in the business. They could be between any two actors. They could be two humans. They could be two systems. It could be a system and a human. But what ends up happening is that a natural distillation of the use case, when you run it through what's called the GWAC stack, or the Grid-Wise Architecture Council stack, which has all the layers, is that you get a bunch of interface requirements, which is wonderful, but it's not the whole story. And so when you're trying to come up with cybersecurity requirements, the use case analysis is only one dimension of it, and that's the point I'm trying to make here, is that system-level security also needs to be seen. And when we're talking about applications across multiple domains, you have to look at security from that end-to-end perspective also. So both are needed. It's necessary, but not sufficient. And then the problem is that asymmetric attacks, and Chris, who's now probably enjoying a wonderful meal in the Bahamas with flames and waves and all of that stuff, knows a lot about asymmetric attacks. And he spoke at the NESCOR conference last year in Washington, D.C. about such asymmetric attacks. And unfortunately, the use case analysis does not grab those asymmetric attacks because the hacker has a different mindset. He's not sitting there going through a use case. He's going to look, or she's going to look for vulnerabilities, and they will exploit them. So after you're done with all the use cases and you've come up with the interface requirements, you got to put on a different hat, you know, a DEFCON or a black hat or one of those types of hats, and say, how can I hit this in an unorthodox way to compromise? Can I grab the CPU and bring the whole system down, including all of its interfaces? Can I do something with the buffers? I mean, there are many, many things that are there besides just direct interfaces on a communication link. We need to think about that. And finally, on cybersecurity technologies as just being part of the solution. I alluded to this earlier when I started speaking, that people and the process have to be there with the technology to provide a more robust framework for cybersecurity. We can't just sit there and say, I met these requirements because I found them in a report, and I'm done. This is great for job security, by the way, in cybersecurity. There's always a job because there's so many things to be done, and you can assure yourself for years if you're methodical. Okay, so now I'm going to see if there are any questions. I see. Oh. All right, so we had a slight technical glitch. I never brought the presenter ball back to myself, so while you were all enjoying these slides, the folks on the other side were only hearing my words. So what I'm going to do just for a moment is show them those slides real quick, and then we'll go into the Q&A. Okay, because my comment section was shut, so yeah, there are only 3. And you will receive, for the folks in the webinar, I have said every bullet on every slide, so you heard it very well. So now what I'm going to do is try to get this session back, participants. There we go. And move this presentation ball back to myself. In the excitement of the Bahamas, I forgot to move the presenter ball. Okay, so just a real quick recap then here. I first spoke about general cybersecurity concepts, and then I went into the problem definition, and these were the bullets I shared about legacy systems and how they are not able to meet the requirements a lot of times for the NERC CIP and NISTIR 7628. And I highly recommend that you go and leaf through those documents to see what I'm talking about. They get quite detailed. It's a heavy read. I have the NERC CIP overall documents, about 1,159 pages in PDF, and the NISTIR is about 300-some pages. But you don't have to read all of it. I would suggest an executive skim to see the categories that are in there so that you can always go back and grab it. Think of it more as a reference document. And then I talked about the TFE and the forklift. And then in the possible mitigations, I spoke about the bump in the wire type technologies, and I made reference to the legacy systems and the old mainframe systems and how we could put technologies in between. And then the gum stick concept, to literally bring the technology all the way to the device and insert it physically into it so that the man-in-the-middle type attacks are kept to a minimum. And then some concepts of re-architecting if there's a better way to redesign the power systems. And for that, I would recommend that you follow the work of Frances Cleveland, who is a consultant with NIST, and she's also very active in NESCOR, and she's done extensive work in talking about how some of the cybersecurity requirements coming out in NISTIR and from NERC CIP can be softened by re-architecting the system. And I would highly recommend that you follow her work there. She's done some very good work. And then some of the critical issues I mentioned about availability. Availability is very important, and so we got to keep that in mind. So what my fear with availability is that you put such requirements on the poor legacy system that by the time it crunches it all, the timeout has occurred on the application, rendering it unavailable. That's the nightmare scenario that I want to avoid. So in the pursuit for confidentiality, you lost availability. That would be tragic. So we have to, when we make these requirements, go into the lab and test them. And there are several good interoperability labs available around the country, including one at the Electric Power Research Institute in Knoxville. And also, NERC has a smart grid lab that they've just recently inaugurated, also in Knoxville. And several utilities, large utilities, have very good test facilities where they can test systems that are interconnected with each other to create a little microcosm of the electric grid right inside the lab. When you do tests like that, and you can even create wide area networks in the lab. You can do it with a crossover cable and have routers and simulate. You can even introduce latency into the network and tune it. All of those things are now possible, but do the test. Don't just say, okay, it works great on paper, so it's going to work in the field. And we have several integrators in the room who do this for a living. Okay, so that's that. So I think that we've covered the slides very well. And now what I want to do is just quickly go to questions. So on the questions, okay, for reference, there is a NICE National Initiative for Cybersecurity Education. It's an initiative by NIST. Yes, so that's the website, nist.gov/index.html. Thank you, Kamran. And then Gina asked another question from the layperson, is the gum stick analogous to the iron key for remote computer users? Does anyone know?
I do. Iron key is sort of like an RSA secure ID token.
Okay.
So in some ways, yes. However, I think the gum stick solution that you talked about had a complete operating system on it.
Yeah.
Not the iron key is something that just gives you a validation, a two-factor authentication token, similar to the
Okay, so
The token storage.
Right.
Identity.
So just for authentication.
Yeah, for 5 tokens.
Right. So the answer is there is some similarity, but it's not quite the full solution the way a gum stick is. This is used for primarily for authentication. All right. So those were the questions online. Let's see in the chat window. Is there any questions? Yes. So please comment private versus public network within utility from security. Oh, wow, that's a nice question. Yes. All right. So public and private networks. Service providers may provide you networks that they will call private, but they're still public. What do I mean by that? They will give you a logical pipe, but they will share hardware along the way, base stations and other things, where the public internet traffic is also traversing on the same physical device, even though logically it's isolated. Now, from a cybersecurity perspective for power systems, I'm very conservative. I strongly believe that if you have mission-critical applications where any kind of compromise of the hardware from the public internet side could affect your logical channels, rendering your mission-critical application to be out, that's not a good way, even though it may be at a very convenient monthly cost. Because the blowback that could occur from having that application out will outweigh your monthly fee. So there are some things that can be done you have to understand that utilities are in a very tight spot. There isn't much in terms of dedicated or private spectrum that is given to them, free of charge. They have to pay for it. And when you have to pay for that, whether it's through LTE technology with service providers or whether it's their own network, if they have to buy that spectrum, it becomes very, very expensive. So if you saw the last presentation on April 9th by Brett Kilburn of UTC on my webinar, the Smart Grid Educational Series webinar, you will see in there that he's talking about the need for utilities to have either dedicated spectrum or shared spectrum with, let's say, public safety or some other group, so that the price point of communication can come down. When you have to amortize the billions of dollars for spectrum over many, many years, over many people, that premium is cost prohibitive. And so that limits how much networking utilities can provide in their infrastructure. And remember, this is not just 4 or 5 buildings in a microgrid. When we're talking about utilities like American Electric Power, you're talking many, many states across the United States. So the cost for networking is very, very high. And so if the spectrum could be provided by the government free, that would be very, very good. So that's my take on, from a security perspective. Of course, if you have a quiet network, right, there's not much noise. It's very easy to see anomalous behavior. When you're dealing with the industrial, scientific, medical spectrum, the ISM band, everybody and their brother is on it. And so when everybody and their brother is on it, sometimes they're twins. So you don't know whether this is a legitimate or a hacker. What's the deal? When you have your own spectrum, you can quiet down the network because it's only application specific. So it's much easier from a security management perspective. If you could come here, Brian, because the folks on the webinar will not be able to hear it.
You can just maybe repeat this. I think another way to think about it theoretically is avoiding common mode failures. So I think putting public versus private is the wrong question. I think we need both and we need more.
Yes. So the issue is how strategic is the value of the data. So there is, in some situations, the public network works fine and it's needed, like a lot of the aggregator model, coming over the public internet to the house, home area network, that's all fine. But I'm talking about like very specific applications that involve protection, on the electric grid. You want to have assurance that the latency tolerance is very tight and that it is indeed secure from anyone from the public internet trying to compromise. So as long as those assurances are there, in certain situations, you could use the public network. In some cases, you would use the private network. You have to look at risk, the price of risk, and then measure it against the cost of communication. So every utility makes their own decisions. But I believe that if dedicated spectrum became available to the utilities, it would change the economics dramatically, and it could give rise to a whole new generation of technologies for communication in that spectrum, and that would help the country as a whole. So we are a little short on time, but I do want to take a break after this. So let's finish these questions real quick, and then we'll go to a break. So the next question here was, wow, people are talking. Okay, so Viv Patel asks, what specific network devices at generation, transmission, and distribution level need to be protected from attacks in the power grid? I guess PMUs is one such device. Yes, PMUs are important. Any intelligent electronic device like a protective, digital protective relay or a digital fault recorder or capacitor banks, if they have a sensor on them and that's carrying the data back, all of these are important. So there's a general category called intelligent electronic devices. And PMUs are one such thing. RTUs, remote terminal units, are another. And these fault recorders, as I mentioned, are others. But there are many, many in that. Okay. And then Bob O'Hagan asks, are there tests that can be run before upgrade or included on Gumstick to see if the target system will have availability, performance issues? Maybe selective upgrades can be done or scheduled even if forklift is too expensive. Yes. So there is a law of diminishing returns where Band-Aids are not sufficient. Then you just need to swap it out. But the forklift I was talking about was just saying, well, this technology is old. We need to replace it. So you have to look at the performance versus effort ratio. Where are you on that S-curve? So if you are in a situation where you're putting a lot of effort and not getting enough performance out of it, then it does make sense, if there is money attached to that application, that you do your return on investment on it and swap it out. Okay, the last question is, you spoke of PHY and MAC layer security. Haven't intrusion protection systems already comprised stateful packet inspection up to the application layer? Stateful packet inspection is a layer 3, layer 4. It's not a PHY MAC concept. You can still compromise the medium access control layer. And I'm especially concerned about the logical link control part of it. So stateful inspection will create a socket. It's going to look at the IP address. It's going to look at the port number against a table and say, yeah, this person can go to this port number. But it doesn't address the lower layer issues. Now, if there are IDS systems for PHY MAC layer type attacks, I'm not aware of them. Okay. Then I think we answered all the questions. So what we're going to do is we're going to take a 20-minute break until 10 after 6. We have some refreshments in the common area. We have chips, cookies, juice, all kinds of fun stuff. So enjoy those, and we will reconvene here at 10 after 6, and there's a nice little lobby area as you saw coming in. For those of you who are on the webinar, take 20 minutes to just chill, have some chai or something. I think that would be good, and we will be back. Chris, are you back on the call yet?
There was a note saying he wasn't coming back.
Oh, there was?
Yeah.
Oh,
I
okay.
saw it. It flashed
Okay.
up there.
Oh, did you?
The Mac dongle?
So welcome back to the second portion of the Smart Grid Educational Series seminar on cybersecurity issues and power systems. We are now starting our panel discussion, and we have a question from Edwin from before the break. He asked, for the power networks, since they have the poles, don't they already have the infrastructure for a private network? I understand that most have already placed fiber on the counterposts. The challenge is not just the physical poles. It is really to be able to lay out a cost-effective infrastructure that can be operated in a cost-efficient manner. If you look at the way the large service providers, the AT&Ts, the Verizons, and others, the way they operate, they have economies of scale. They buy spectrum. They amortize that cost over many, many subscribers over many, many years. And their base stations that they use for communication are multiplexed. And so they're not sending data of just a single user or a single company, but moving a lot of data for a lot of people. And that cross-subsidization helps them stay competitive. Now, when we're talking about a dedicated network for a utility, quite often utilities do that in order to avoid having devices not being networked because maybe the service provider is not available locally to give them that. Or they have such tight time requirements that even though their network might be primitive, because that is only carrying that dedicated data for that application, they can say that the tolerance for the latency is very small and it's very tight. So they're getting the high quality but very, very limited amount of throughput. And so there are a lot of these mission-specific type networks that exist. Many times you'll see twisted pair running along the transmission line. And you will see that with master-slave token passing protocol, MSTP. And very, very low bandwidth. In many cases, you're going to see serial interfaces with like RS-232 type connections or RS-485 type connection where you use the twisted pair. So there are these protocols that are there. They provide in the tens of kilobits, sometimes low hundreds of kilobits, but it does the job because it's just focused for those specific applications. So when we're looking at networks, we're not just looking at the cost of putting a pole. Yes, that is an important part of the cost, but the communication infrastructure that needs to go in place and doing it in a cost-effective way. So my crystal ball tells me that if dedicated spectrum was given to the utility industry, or if there was shared spectrum, like with public safety, let's say in the 700 megahertz range, you're going to find a whole new set of companies forming in the telecom industry that will provide boutique solutions to the utilities. In some cases, they will remain as standalone companies. In some cases, they might become wholly owned subsidiaries of the utilities. And then you will also see the service providers, the big ones like the AT&Ts and Verizons and others, come into this spectrum and provide dedicated networks to utilities because it would make it worth their while also, since they will not have to pay the premium for the spectrum just like other people would. So there is a new wave of communication technology and prosperity that will come with it that's just waiting. But the problem that we're facing in the country right now is that while there are groups advocating for this, it hasn't really picked up. And people are just, everyone is basically on the fence. And everyone is looking at the pros and cons of the situation. But I believe that if smart grid IQ needs to go up, there has to be plenty of bandwidth, because the smart grid applications of the future are going to become increasingly more byte intensive. And you can get some advantage by having a distributed network and pushing out the intelligence to the edge. But the more granular the data you're going to collect to do network operations work, you know, the log files of all these intelligent devices, you're going to, even if you bring back summaries, you will still need a very reliable high-speed network. And so the future doesn't bode well for very, very narrow bandwidth networks, except for very application-specific purposes. But the general purpose pipes that T&D and also the edge will need will have to grow in bandwidth. Anyone who will question me on that, I will ask them, remember the modems with the two pillows, the 2400 baud rate? I used to use one at Lawrence Berkeley Labs in 1984. And if someone told you today that they'll give you 2400 bits per second, you'll laugh at them today. When I got 9600, I didn't know what to do with all that extra bandwidth. So it's just a matter of time, and we will face that. Okay. So moving along, are you in a position now where you have, oh, it's on the stick. Okay. So I'm going to upload a presentation by David Bowles of Wavestrong, and if I could pull this off. And we will be bringing up the presentation from David Bowles of Wavestrong, and then we will go into a Q&A with him on this. So let me see. Oh, there's a quick question here from Ravi of Hydro One, who asked, Canada CRTC has allowed the 1803 megahertz spectrum to be used exclusively for smart grid applications. Yes, thank you, Ravi. I'm aware of it. And 1.8 gigahertz is a good frequency range. It is below the 2.4. Remember that the higher the frequency that you go in communication, I'm talking now, he's specifically talking about wireless communication here. So the higher the frequency you go into, the more optical-like the phenomena gets. So what that means is that when you have barriers, it's going to create shadows. The lower the frequency, the more is the diffractive process that occurs around buildings or around barriers. And so 1.8 gigahertz is definitely better than 2.4 gigahertz as far as that is concerned. But the closer you get to the 1 gigahertz, and if you can get below the 1 gigahertz, it's good. But from an engineering perspective, the antenna geometry actually becomes more and more miniaturized as you get higher and higher in frequency. But the cost of the base stations also goes up. On the low side, you may have less costly base stations, but more kludgy antennas. And I know all of this because I've seen an expert really work on this for many years across a wide spectrum. And he's in the room right now, and he's smiling at me. Okay. So I have also seen Bondu applied to a helix-type antenna for certain frequencies also. So all kinds of geometries do exist, and we try to do the best we can. So David, if you would like to come to the front, and I will just introduce you as in the management of Wavestrong. And I sent you all a description of Wavestrong. They provide a variety of services, including integration services, and they do evaluations, and they do security assessments. And this company was founded by Harpreet Walia, who I had the privilege of working with when I was a consultant at Wells Fargo about 7 years ago. And he's quite the entrepreneur and a real industry thought leader and always like one step ahead of the game. So I'm very privileged to have David here from Wavestrong talk a little bit about some of the challenges that we have in cybersecurity. So David, you can just move the slides right here, as you can see, right there.
Right there. Okay. Well, thank you, Arifan. I appreciate it very much. So when Arifan asked us to share some of our thoughts around the challenges in cybersecurity for power systems, we looked at it a little bit differently, and I'll actually go back to giving back IT security a little bit of credit. I think a lot and most of our challenges that we've actually faced in IT and IT security and the evolution of the internet and the things that we're doing today, we've addressed a lot of the same problems that are now going to have to be faced by the power system. As Arifan mentioned earlier, we went from mainframes that didn't speak in TCP/IP. The communication protocols were established to be able to do things, and we found ways, and I'll use the term, and it comes from the credit card industry or payment card industry, of compensating controls. We will find ways to introduce compensating controls to present security solutions that will achieve the various things that we have, various challenges that we have. That being said, I don't want to diminish in any way, shape, or form the importance of security and cybersecurity specifically. The areas, and if you start to look at all the various applications that we get into when we start to talk about smart grid applications, the invasiveness that they can present can be very, very, very impactful. So we need to look at those things. Your cars, there was a little bit of discussion during the break, but if you have an electric vehicle, now your electric vehicle, and you plug it in anywhere into the network, you're identified exactly where you are. Do you want someone to know each and every place that you drove, plugged in, and exactly where you were, what time of day, and all your usage, where did you go? Because now your GPS data is also being downloaded, and where you traversed. There's a lot of invasiveness that we get into. There's some refrigerators that will be able to put your shopping list. You'll be able to go type them up on the screen, and they'll email them to you or send you an alert, oh, your milk is low. You need to buy milk. Well, that information is going to be very powerful and meaningful to a lot of different people. Us as consumers, it'll hopefully make our lives easier and better, but there will be other challenges that will come with that, and privacy will become necessary for those things. So, again, I'll kind of talk to it more from an IT security perspective. That's the background where we do the most of our consulting and professional services and helping companies to bridge those gaps and face some of the new challenges that they have that are continually evolving. But again, I don't think it's something that is so undaunting that we can't get to those things. So let me just forward here. Yeah. Right there. So I'll get this out of the way. So in IT security, we typically ask a set of pretty simple questions. We do have some things now when we start asking questions about smart grid and power systems. The answer is a little bit different than some of our typical IT responses. So do we know who's on our network? If we're a smart grid or a power systems operator and we're collecting private data about our consumers to deliver better services to them, we need to know who else is on those networks and how to control them. The other thing is, and IT security faces this challenge today, and understanding where is the perimeter. The old idea of security was build a big firewall, build a big wall around the castle, dig a big deep moat, fill it full of water, and you could control access. And you had the soft, gooey center. Well, today, our perimeters aren't the same. How many people have smartphones in their pockets? This is a perimeter. Because now I can access, in a smart grid application world, everything that's going on in my home. I can control my power, I control my lights, I can turn on or off my security systems. Everything that I'm doing can be controlled right here. So this presents a whole other level, another ingress and egress point of where do we need to be concerned about the security and privacy of our data. So just as it expands, and it continues to expand. Corporate IT today is facing this challenge in trying to protect their data, their privacy of the company assets already. So again, I think we'll have solutions, and that there are solutions that we can begin to migrate over into the other world. So how are we currently protecting ourselves from known threats and vulnerabilities? Again, common, everyday corporate IT question. But the challenge here is we've got new applications, a new set of perimeter or parameters for which that we need to be focused on protecting, and we'll need to know what those are. There's also these new threats. We've talked about vulnerabilities, and that's a pretty common term in IT security. But one of the areas that we've not put a lot of thought, or there hasn't seemed to have been as much thought, is how are we going to protect against threats in legacy systems that weren't designed or built to be upgraded. Those systems are hardened and not as simple as being able to update our iPhone iOS or our laptop operating system, getting patches. Some of these systems don't have the ability to. So that's where we're going to need to come in when I use the term compensating controls. Do you have visibility into your infrastructure security posture and corporate compliance standards, both network and remote systems? This is hardwired, non-hardwired, the extended litany of our network and what it will become. Is our posture and internal standards, and this is one of the things that will continue to go on, and corporations face this every day, is balancing IT risk versus their investment, and what is the reward or trade-off in that. So the age-old insurance, kind of paradigm of what is my exposure to lost information or data versus how much is it going to cost me to protect myself and protect my customers. These are going to be questions, and it really comes down to compliance or corporate responsibilities that people are going to have. The federal government and different legislative bodies are going to come up with all sorts of different rules and regulations. I've been in IT security for 15 plus years, and I haven't seen any organization be able to deliver a set of standards that gave anyone true security. I don't think there ever will be. It's going to be a community of people that are actually going to do that. And that'll be the people that have the actual stakeholder interest in those, because they're going to be able to compete and buy for our business in a true smart grid application environment. There'll be more competition, and they're going to want to protect us. I'll go back to the analogy of a bank and our real world situation that we have today. Banks compete for us, and if we don't believe that they're trusted or secure, do we want to go put our monies with them? We've heard all sorts of issues and complaints about different stores being compromised or having our credit card information compromised. I've had several clients, and it's kind of interesting and funny to be back in this building. I left IBM about 2 years ago, where I did a fairly large stint in my security background. And some of the clients that I had, one major retailer had a security breach, and they lost 65% of their credit card transaction business for 6 months. For a retailer that does 87% of all their transactions were credit card, these are face-to-face. These are in-store transactions. That 6 months cost them billions. Those are huge. So that's the cost factor. It's not just the monetary loss of losing the information, which was very costly to them, but it was the lost sense of trust and the relationship they had with their consumers. So when we look at this bigger paradigm, again, it's not just as simple as do we protect data and how do we create privacy around the data. It's really what are we doing to protect our brand, our interests, etc. All of these lessons, again, have been learned in corporate. Corporate IT has been going through these and evolving through these for a while. So the next question is one that gets kind of sticky for a lot of people. How long does it take to discover systems out of standard? And once identified, how long does it take to remediate? Apologize for the typo on the remediate. So how long does it take for those? This is probably the #1 sticking issue when you talk about corporate IT security, when you're going to talk about smart grid or power system security. Understanding where our faults, knowing what we don't know. It's kind of interesting. I put this together earlier today without knowing what some of the other presentations were actually going to entail. But not knowing what we don't know is our biggest enemy. And being able to have information, and this is probably the #1 thing that our firm consults on today, is understanding where the problems are. It's okay to know what they are. We want to know what they are, so that it helps us to remediate and take care of them. If we don't know and we stick our head in the sand and say we don't have any problems, that's when we really have problems. So being able to speed up this process, and as we start to get into the multiple systems that we've heard talked about today, all across the board, that's going to create even more confusion on what information is where are our vulnerabilities, legacy systems to new systems, the communication links between those, the various layers, applications. Getting that to there is going to be being able to understand it and know it in a real-time world is going to become necessary for us to have that information in real time. That's probably the biggest challenging or roadblock that we have right now to effective security controls, is really information to do what we need to do. Go to the next slide. So, what is the answer, or what's the driving force? The thing that we consult the most, and I pulled out 5 of these blocks to just kind of give some relational value to, this is all for corporate IT, but every one of those blocks will come back to power systems and smart grid networks that were going to be developed and pushed out in the future. So the real solution is, real-time challenges require real-time data and information to effectively remediate them. How do we get that? That's going to be one of the biggest challenges. There's different benefits of that. Outage management, if we can handle outage management in seconds versus hours and days because we're trying to collect data, that's going to have a huge cost benefit. And make no mistake, these smart grids, power networks, power systems, at the end of the day, we as consumers will be the ones to fund them. We're the ones to pay for them. We're the ones to pay for their successes and failures. And if we can, in the same way that corporate IT spends their dollars and investments in IT purposes to profit them, if we look at it the same way and give them the same tools, look at the same way of fixing the problems, they'll be able to actually do these things and deliver more services to us for less. So going over to unmanaged asset tracking, probably one of the biggest concerns in IT, corporate IT environments today is not knowing who's connected to their network and when. It introduces both just, what can they steal from the network? Am I trusted? You heard it earlier today that somebody plugs into a network in a corporate environment and they're automatically trusted. That's pretty dangerous. There's a lot of companies that are getting away from that. But the other thing is that also, if I connect to the network, IBM was gracious enough to let us all connect to their wireless network, but if my computer, my asset is full of malware and I can introduce it back into that environment, now what? We're going to have services and products that are going to connect to these power systems and smart grid networks through applications that can be manipulated or have malware that can present back and damage and take down the rest of the network. So again, these parallels are all the same. Software licensing, again, from the IT world, understanding, historical uses, using or disabling applications that aren't being used, or disabling applications that could be malicious or damaging. These are again, smart grid applications. Think of those in the same parallel where they're going to need to control them. Emergency patches and updates, being able to apply third-party patches. So, I'm Microsoft. I went out and built a smart grid little application. It's called Windows CE, or a derivative thereof, and I embedded it in a refrigerator. Somebody goes and creates a piece of malware code and It's connected to the Wi-Fi network, my wireless area network. Now it comes over and searches out and finds my refrigerator, plants a big pile of malicious code in there. Now it can dump it up, and it can infect, all of my computers that are connected to the network, and also infect all of the service provider exchanges that are in between me and the power system supplier, as well as the power system supplier. So now what's going to take? I'm going to have to get a third party, because I didn't buy my refrigerator from Microsoft. I bought my refrigerator from Whirlpool. So now I have to go to, Whirlpool has to go to Microsoft and get a patch and fix this. Today, this is occurring right now. There are vulnerabilities present today in some of the smart televisions that we have out already. They're attacking in multiple fronts. Samsung has wireless enabled LED TVs, and they also have Bluetooth connections to them. And both are on by default out of the box. So I can walk in real simply. I can connect to the TV in your home, any one of your homes, upload through the Bluetooth connection, malware, and now it's on your TV, broadcasting to your internal wireless network. It's that simple. So we got to be able to know when this stuff is going on and how do we do it, and then how do we patch it and protect it. The next one is, audit and compliance. We're going to need to manage that data and bandwidth. We've heard talk about, do we get the public sector network, public safety network? We're still going to want to be able to control that, because more and more data that we can push through our home appliances and home networks, through the smart grid and applications and power systems, is going to continue to grow at a huge alarming rate, and we're going to need to be able to control the bottleneck at some point in time, or it's going to stop control of being able to deliver services to us. So is there a solution? I can tell you there's solutions in the world today that do all of this right now. One of the other areas that we do, in addition to consulting, is actually corporate IT consulting, is also around new product companies or new technology companies that come into the market space, and helping them to figure out how to fit and hit the gap and make up for some different deficiencies. This is specifically pulled out of a systems management technology company that's brand new, just came out of the market. And this is what they're actually able to do today and could be doing for other systems, other power systems, smart grid networks, et cetera. So again, I just kind of give a little bit of background of what are the challenges. And my basic premise or basic response is information is going to be critical. We need more and more information, and we need to be able to have it in real time. You hear these same things being said about smart grid applications and all the rest. The way that we're going to fix our problems is learn from our lessons from the past and use the technologies that we have today to create compensating controls until such time as we can massively uplift and replace those. Just a little bit of background and overview on some of the products and services that we, Wavestrong, provide and kind of our overall background. Any questions? I'll let you come back up.
All right. Yes.
Yeah.
Yes. So thank you very much, David. And let's see if we can get this going. So this concludes the presentation part. So we're going to just spend about 15 minutes in an interactive Q&A session. We can talk about anything and everything during this time. So what I would suggest, David, is if you come to this side by the microphone, so the webinar folks, and then for the people who are in the room, if you want to come and ask a question, just come straight to the podium, or the lectern, actually, not the podium. And then ask your question, and then we will answer it. So this way, the webinar folks who felt a little neglected when I didn't move the presenter ball I'm walking an extra mile in their direction right now to make sure that their needs are met. Okay, so let's see on the chat if there are any questions. Okay, it says, Irfan, I'm told that Chris won't be able to rejoin us. I can dial in under his code and take some questions where appropriate if you like. Oh, that's his brother. Okay, so that was very nice of him, but I don't see any questions yet. Let's try going a little further here. We've seen these questions before. Okay, this looks like a question. I guess that was already done. Okay, so any questions from the webinar folks? This would be a good time to put those questions up, and we will take them. No questions there. Any questions from the audience? We have had a very quiet audience today, so please identify yourself to the folks on the webinar.
Michael Flores. I guess my question is, in doing the security, are we moving more towards the hardware type of a box where you're going to stick in a particular facility in which you can then upgrade security data to it and then it will do the monitoring, or are we looking at, you know, centralized controls or whatever?
No. No to both, I believe, is probably the right answer. There will be multiple layers required in security. It will always be that way. I don't believe that you can go give a silver bullet to the network because you have applications, you have different protocols, you have different forms of communication, different types of communication that has to go through. So I don't think you're going to have multiple. You're going to see different philosophical opinions on, is it better to go with hardware-based security versus software-based security? And different companies will go different directions for those based upon their appetite for risk, and you as a consumer will make a decision. What do you do at home to secure your local wide area network or in your wireless network at home? What are you going to use? And part of that decision will be ours. So it'll be based upon your risk tolerance and risk factors, as well as what companies and the power system providers and smart grid application companies provide.
Is there any way in which, I mean, I don't see any way that you can make something absolutely secure.
No, there is. Yeah, you can.
Well, unplug it. Unplug it
and don't let it, and that is security. But back in college, and one of the few things I probably learned in college, Business 101 was, you know, going into business, there's a risk. And so going into smart grid and using smart grid applications, there's a risk. There's a risk for us as consumers to use it and consume it. There's a risk for the companies that provide it. And that risk tolerance, which is different for everyone, and one of the things I probably learned the most in my consulting background is that my idea of risk and your idea of risk and the clients that I serve will always be different. I'll advise on what is the industry best practices and standards, but the actual risk tolerance will always be different.
Thank you. If you could identify yourself and ask the question, please.
Hi, my name is Subramanian. So I guess what I was going to ask touches upon that last point that you were just commenting on. So in the work that you've done with the utilities or the power companies, what is their notion of risk and risk tolerance? Because as Irfan was saying, you know, IT security is only one little bit of the overall system security issue, and at some level, they can either adopt the attitude, we just want to be compliant with whatever regulations we deal with, or they might have some, you know, more broader, overarching, and more, say, meaningful or insightful notion of security. So what's been your experience?
My experience has been mixed in a lot of ways. People, if you ask any IT security professional working in corporate America today, they will always have told you that they wanted to do more. It's generally budget, and the people that make the decision on the risk tolerance are the executives of the company that are, fiduciarily responsible for those activities. So I consult with a lot of CIOs, CISOs, and their risk tolerance may be totally different from that of the CFO. So there's a different mindset going into each one of those equations. What do they want to do? IT security, I've never seen an environment where IT security didn't want to do the absolute best to protect the security. Were they given the funds or resources or the ability to perform more beyond just compliance? That's an individual corporate decision that's made. And they don't always control that. So.
Right. So I guess my question was, have you actually done any work with the utility companies?
Yes, we
so there would be more than so. I guess is their perspective on this broader than just the IT security? Because as you were saying, it's a lot more than just IT security. And of course, the CFO and the CISO will always, quibble.
They don't always see eye to eye on those things.
Yeah. Right.
So the other part of it, what I would say is we find in our consulting engagements and what companies are beginning to realize, power companies, I'm not going to use a differentiator today, but companies as a whole, IT security is now not just IT security. IT security professionals have had to look out and go, wait a minute, I got to have a little bit broader vision. I got to look at a bigger spectrum. And network IT or systems IT or other portions of IT, or even business owners who are financially business-driven in the organization have to take wider views to understand the importance of IT security, but the IT security has to take a wider view, say, I need to be able to look at a broader set of data and protecting, and how do I go about protecting it. So that's what I would say is IT security. Security is not just security. It is now a full function of IT, and if you put it in the full system lifecycle of IT management as a whole, as an integrated whole, then you get a greater result and higher yield from the result. I think the same thing is going to occur when you talk about power systems and smart grid applications. The same type of chasm will have to be crossed, but I think that, again, we've learned the lessons. Smart companies, big smart companies that are making very profitable today, have learned that they can do things securely and by involving security early in the process and building better systems and better applications and better services as a whole. I think the same thing will occur. Now, I do see that. I do have power companies today that do that today for their corporate IT. They haven't gotten to some of the other areas in the smart grid or power systems because they haven't been forced to go there. It's going to change really radically here in the next probably 6 to 12 months as we start to force adoption of smart grid applications and systems. So there'll be some lessons learned. There'll be some bumped knees along the way. But yes, I do believe that they'll be able to look at the bigger picture and not have a siloed. Siloed approach is never healthy for security or IT security.
Yeah. One comment that I'd like to make at this point is that with electric utilities, they have been doing business a certain way, and it has worked very well for them with 5 nines of availability for electricity that we all enjoy. The future prospect for 5 nines of availability is really questionable. And from a supply perspective, a lot of the generation plants are going to reach their end of life cycle because of environmental concerns. A lot of the coal-fired plants may not be able to come back. And with the controversy that's going on in the nuclear industry, which is 21% of our energy mix, you can imagine that if we don't start licensing nuclear power plants now, you can imagine that once those power plants reach the end of life, they will have to be replaced. And if you look at the renewable portfolio today at between 3 and 5% nationally for energy mix. Some states may be a little higher. I'm talking solar and wind, not so much hydro in that equation. Then we have a real problem facing us from a supply perspective. So that means that in order to have this intermittent resource, solar and wind, buy us the time until we get the next ultimate source of energy, which I believe is nuclear fusion power, but it's always like a mirage in the desert, 30, 40 years away. And I know because my degree is in that field, and I learned how to dream early. So the challenge that we're facing with the supply is that we have to go to unfriendly territories. Unfriendly meaning that the supply is intermittent, which means that the demand will have to follow supply. Demand following supply means demand response. Demand response means invading people's privacy and altering their behaviors in real time. And if anyone has lived in the United States long enough, you know you don't mess with anyone inside their premises. Half of them have guns. More than half. Okay. Yeah. So I am very, very concerned from a quality of service perspective. And this will not be the fault of any utility. I mean, they are, bounded by these political and economic realities. Then throw on top of it the need for cybersecurity in this highly networked environment. It's a challenge. So there are ways in which we can address this. Collaborative research is one way. Come up with requirements that has consensus in the industry, that allows integrators and vendors especially to work together to make sure that the solutions that they're implementing in the infrastructure are realistic, affordable, and over a long period of time can provide the security. In other words, they're future-proof. Future-proof means that you can add things to it, that it's not a dead end. You don't have to make awkward U-turns, that kind of thing. So in the choice of technologies, it will be really important. Then what we're really lacking is a real robust network management layer on top of all of this. Security, the life of a security person can become a lot easier if they had more visibility across their infrastructure. They don't today. A lot of them are proprietary, vendor-specific microcosms of reality, and they are sitting there with displays from multiple domains trying to make sense of it all. A hacker who's interested in a coordinated attack finds this fertile ground. So if we're going to avoid future attacks, I'm talking about, we always talk about the foreign agency or country. Inside, in the United States, industrial espionage rings, people who offer 2 W-2 forms, one for the company, legit company where they work, and the other one for the espionage company. So they are in the business of collecting data. And that data, as Miranda writes, shall be used against you one day. So these are the realities that we're facing. And so having that network management layer, having the ability to visualize and see anomalies and be able to correlate events requires a metric. We used to have this metric in enterprise networking with SNMP. It was rudimentary, but it did the job for routers and switches and so on. We don't have the equivalent today for smart grid. There's no vocabulary across the board. IEC has in their standard under 61850 space for it, for future, but it's not populated yet. So we have to start thinking about how do we write sentences when we don't even have words with meaning. This is our reality. So we have a lot of customer-specific solutions being given by integrators because there's nothing else. So we have to create that awareness in the community, in the industry. I'm not talking just United States now. This has to be an international effort. No vendor is going to sit just in the US border. They're going to look for markets overseas. So we need to have this consistency in cybersecurity and create a metric so that we know what the cybersecurity posture is. We need some cybersecurity chiropractors to tell us what the real posture is. We're missing that. I mean, I use the term in jest, but it's really missing. So it's like apples to oranges comparison. How do you know how good it is? Oh, it's very good. Why? Because I say so. I mean, so these are the kinds of things that we have to get over. So collective efforts like the NIST CSWG, the DOE efforts through NESCOR and NESCO, the NERC work, the OpenSG work, all of this needs to be tracked. And so I'm motivating all of you to reach out to these groups, put in your creative input. That's a big part of what the Smart Grid Educational Series is about, is to bring people who are not normally in the discussion into the discussion and get their creative juices flowing and get in there and start affecting. A lot of these working groups, unfortunately, are facing dwindling attendance because, you know, people are concerned about money and they're trying to do billable work. This work is not billable. You know, what do you put it on? But as a national priority, we really need to think about it. We'll take one more question because we are at the top of the hour. Identify yourself, please.
Jamal Rawi. I have a basic question, and it may, after this beautiful presentation by Irfan, this is very basic. Most layman people, may not include myself as far as defining security. I understand it's a broad definition, but for the layman person, it's basically accessibility and protecting against malware and probably viruses. And my question is that, first, what's the difference between a virus and a malware is a basic question. And the second is that to protect against both viruses and malware, if those are the only Trojan attacks, is that do you block the accessibility of the attacking entity, or do you have specific engines that actually detect latest and updated Trojan attacks?
So viruses and malware. Viruses have become kind of, they're more, I'll call them nuisance-oriented, cause minor disruptions or more minimalized interruptions. Malware can actually take actions. So your first part of your question was, you know, what is security? So security is the protection of information. That's it. That covers all of it. So it's
not including functionality. Secure, if I could bring the system down, shut it down.
That's an information. That system is an information. It's based upon information. If I take down that system, then I'm stopping the flow of information, and I've compromised that information. That's what brings down a system. So it's access, it's securing the data, the information that's in the system, stopping or allowing access to the information. Malware can take on, you know, remote actions. It's not just viruses. I can do a SQL injection and get into a database that now, because a database is called from an application, that application now calls the database for information, and now I just go infect the database. So it becomes a lot bigger way. There are multiple methods or targets to get through to compromise the systems. But it's protection of information. Everything is, the ones and zeros are what we're trying to protect. And that's what controls the operating system, or the system that's actually running the system, the databases, the applications that are calling the data, the systems that are delivering the, you know, the on-off switch to the power.
If you could imagine that you'd have, I mean, here everyone has a PC and they're worried about protecting their PC. But imagine having a smart grid where you could have 140 million or more, probably much more sites. And if you're trying to protect against a virus, and then in our case, every 2 days you're downloading new software, whatever that is, to protect against viruses. Imagine that you have 140 million sites that you need to protect. You know, the question is that when you're protecting against viruses or malwares, you have to have a specific engine that needs to be constantly updated. Is that correct?
Yes.
And it's not just blocking somebody's access. I mean,
it's not access. No, it's blocking the data, the malicious data, or the malicious code that's embedded in the data. If it can detect it and then block it.
But from the work that I've done in that area, that's the update portion of putting the protections, which needs to happen, could happen several times a day possibly, for all practical purposes. You need a huge amount of bandwidth to transfer so much data all over the country, and then it comes to the point that Irfan mentioned, that you really need the high bandwidth, and we haven't even started. If you want to go into that route,
okay.
And you know, you may know more about what's the size of data that needs to be transported to do the protection constantly.
No, I can't say that I do know, and I don't think anyone could with any reasonable certainty, because it's a very uncharted path. The amount of bandwidth, you know, we'll probably see a lot of these protections begin to take place, at least detection and attempts to block them actually in the power systems or smart grid network system, where they'll begin to be blocked at the network layer versus having to be protected all the way down. So we have service providers that do that today, that protect you, like AT&T, ISPs, et cetera.
Because of the lateness of the hour, I just want to conclude these 3 questions, and let me just request from the host if another 5 minutes would be okay. Thank you. All right, so the question is, where do you see ICS SEIM, which stands for Security Events and something Information Management, and ICS Network Security Visibility Importance in the Utility Security Architecture? And this is asked by Chris's brother, Brad. And I think that this particular idea of normalizing the data from different security tools, if you may, and bringing it back, of course, the people in the Network Operations Center need this the most. But it also becomes a very good currency by which you can exchange information with the independent power producers, with the aggregators, and with other stakeholders that the utility is working with. If you don't have the data normalized, it becomes very difficult to share it in a meaningful way. So I see this importance in multiple, yeah. Go ahead.
Just to elaborate on that, you know, IBM, I work for IBM, as I said, they have a research and development organization called X-Force that does some of the most advanced security research and development on malicious type internet or security activities around. They collaborate with all of their competition. They provide that information to their competitor software manufacturers. So IBM would do research, find vulnerabilities about Microsoft, and tell Microsoft before they told the world. Give Microsoft a chance to fix those. There's a lot of co-opetition that has to occur for all of these things to work. And that is that all of us have to collaborate in the industry to bring best practices, but to bring research and knowledge to finding the solution.
Yeah. The key thing is that proprietary brings you quick to market, but it will not give you longevity. For longevity, you need to be standards-based, and you need to differentiate your product not by how esoteric your data formats are, but by the customer service, because that positive referral service from customers will grow your business, and you make money from the volume. The innovation should be in how you architect the internals of your product, not the information exchange portals. That should be all standard. It's how you optimize the engine, and there's lots of room for innovation in the design of systems without having to resort to proprietary protocols and standards and network management GUIs. Okay, just 2 questions left. First is, are there different cybersecurity issues for renewable energy at the generation level? Well, the renewable energy at the generation level are large things like we were thinking of compressed air energy storage systems. We're thinking of very, very large wind and solar farms, those kinds of things. So what needs to happen is the same concepts of the confidentiality, integrity, availability, accountability, and all of those things, all the ITIs, what I call non-functional requirements, need to be in place. But also understand that with renewable energy, there's a lot of geographically distributed networks where a hacker may even have access physically to those intelligent devices simply because of the layout. So you have to start thinking about how do you create situational awareness so that physically induced attacks, where the hacker physically comes and puts something in some port. Make sure that those ports just are not sitting with RJ45 connections open so that anyone can put and immediately be trusted. Having the proper authentication, having the proper verification, and having white listing of applications so that if a particular application is not in your list and they're trying to download it and you're like, I don't think so. So those kinds of best practices need to be in place. When you have a big wall with fence and barbed wire, it's different. But a lot of the renewable energy fields are not like that. The hacker will have access to them. And then, huh? Yeah.
No, there was a comment that just popped up in the
like Cisco's console port. Okay. Yeah. Well, let me just say, for the sake of neutrality, vendor neutrality, that any vendor's product can have ports. So it's not just Cisco. Okay. The last question is a good one. And this is from Dale Gutierrez, who was planning on joining us, but because of some ailment, he was not able to. But even without immediate physical or logical access to a target, isn't there some importance in the threat of hackers siphoning control data? Yes, we had a comment about that at break time. If hackers can attack security components like passwords to later consummate an attack, I have never seen this choice of words, but okay. But seriously, the issue is that the confidentiality that is needed in the power system, I was corrected at break time by our illustrious attendee here, who said that a lot of times passwords, access information, can go back and forth over these networks, and that needs to be encrypted. So, because if somebody grabs that, then they can not only steal data, but they can also fuzz the data because they'll have access to devices at a later time. So we have to strategically encrypt things. But when I was talking about the confidentiality aspect, I'm talking about bulk data all being encrypted, and then every time you want to run a SQL query, it'll take forever to unencrypt and run the query and then encrypt. Those are the kinds of things, the busy work that we want to get away with and become a little more intelligent about how we apply cybersecurity. Concluding remarks, cybersecurity, as you know, is very important, but cybersecurity is not important a la carte, like in a restaurant menu. Cybersecurity has to be seen in conjunction with network management and physical security. And physical security together with cyber, this whole area of cyber physical systems needs to be looked at. And the advance in sensor technology today is opening new opportunities for our industry, for the electric sector, to start converting analog information, human information, physical phenomena information through sensors into digital information, which can then be fed back, and you can create a new type of situational awareness so that you're not just looking at zeros and ones being stuffed, but you're also looking at the corrosion of the pipes. You're also looking at the temperature of the transformer next to a Tesla. All of these things are important. So cybersecurity with physical security and network management coming together with a metric, a language by which multiple vendors can exchange information will create a whole new level of security, safety, and reliability. So with that, I thank you all for participating in our second Smart Grid Educational Series seminar and webinar. I hope this was informative for you. please go to the websites for NIST.gov/SmartGrid, go to the NERC.com site and download the document for the NERC CIP guidelines. Also go to the DOE site and look at their 10-year roadmap for the energy sector. You'll find very valuable information. And also on the NIST website, you will find a General Accounting Office report on the electric grid, which I think is worth a read also. So with that, thank you very much. Thank you to all those who are on the webinar, and have a wonderful week. Our next webinar is going to move from Tuesdays to Mondays, so I'm going to ask Chris about availability on the Monday, and the reason is because the Tuesday conflicts with the class at Foothill College, and there are students in this seminar who are coming here who need to go to a 6 o'clock class right afterwards. So it wouldn't work on the Tuesday format. So I'm going to discuss this with Chris of IBM and see if we can do it on the 4th Monday of the month as opposed to the 3rd Tuesday. Yes, so the answer is maybe, and we will give you further guidance in that. So thank you, and have a good night.